Let's go through a few graphs so you can determine symmetry. So if there is symmetry to the y-axis, this is your y-axis, that means that a point jumped across the y-axis the same distance. So notice right here, this point is a distance of 2 away from the y-axis. If I jump it across the same amount, it would land right there. Or if I took this point here, it's this distance away from the y-axis. So if I jump it across the same distance, it's over here. So this particular parabola is symmetrical to the y-axis. Also, if this was on a sheet of paper, I could fold on the y-axis and everything would match up. So here's an example of symmetry to the y-axis. Now let's take a look at one that is symmetrical to more, well, let's try one that's symmetrical to the x-axis instead. Let's see if I can find just a quick obvious one. There are several in here, but, well, this one has a lot of symmetry going on. This one is symmetrical to the y-axis because if I take this point and I jump it across the y-axis, it's over here. If I fold along that y-axis, everything's gonna match up, so this one is symmetrical to the y-axis. But it's also symmetrical to the x-axis. If I jump, say this point right here, if I jump this point and I jump it across the x-axis, it would land here. If I have this point and I jump it across, it's gonna land right here. If I fold along the x-axis, it's gonna match up, so it's symmetrical to the x-axis. The one that is a little bit more challenging to understand is symmetry to the origin. It's basically folding across the x and the y. The way I like to describe it is you can take any given point and jump across the x-axis and then the y-axis, and it matches up. This particular one is symmetrical to the origin as well, but I'm gonna pick a different graph just to illustrate that. Okay, here I have the sine curve. So I just go to any point on the graph. So let's say I go to this point here. If I reflect this point across the x-axis, it would land right here. And then I turn around and now reflect it across the y-axis. It's 2 away, so I'm gonna jump it 2 away and see how ultimately I land on the graph. So this point to this point, I can grab just some other random point up here, maybe this one right here. If I reflect that across the x-axis, that would put it right about there. And now if I reflect this point across the y-axis, it's 1, 2, 3, see, that's 1, 2, 3.5-ish. So let's jump this way, 3.5, 1, 2, 3.5. And see how I land back on the graph. So this one is symmetrical to the origin. I think it's worth maybe doing just one more of those that are symmetrical to the origin. This graph here, just quickly, if I reflect every point across the y-axis, it's a match. So this one is symmetrical to the y-axis. It's not symmetrical to the x-axis because the points don't reflect across the x. And if I grab a point and jump across the x and then the y, it's also not a match. So that one is not symmetrical to the origin. Here's a good graph to look at. Okay, if I take this random point right here and I reflect it across the x-axis, that would put it here. And then if I turn around and reflect it across the y-axis, it's right there. So we land back on the graph. So the key is, if you take any point on the graph and reflect it across the x-axis and then on the y-axis, and you land back on the graph, then it's known to be symmetrical to the origin.